Welcome back, students. Today we are going to learn about new chapter, time and motion. Children, open your textbook at page number 185, chapter number 13, time and motion. Shall we start the topic? Yes. Yes, children. Now let us learn about the mind map for this chapter. Okay. So here the unit is about measurement. The chapter name is time and motion, but still the unit is based on measurement. So what is measurement? Whatever we are buying, vegetables, oil, grocery, milk, everything is measured in a standard unit, is it not? Yes. So measurement is important. Okay. So the proper definition for measurement is comparison of unknown quantity with a known quantity of a same kind. So one side we are having unknown quantity, might be some 4 to 5 kg of vegetables. So we want to measure that 4 kg of vegetables with a known quantity of same kind. So in the other hand, we'll be having known quantity as like 1 kg weight or 2 kg weight. So here known and here unknown. So we are measuring the unknown in terms of known. Is it not? Yes. That's what measurement. Clear? Yes. Now further, measurement is also, we are applying this measurement. We are applying this measurement in time, motion, speed and all. Okay. So first about time. So what do you mean by time? It refers to the interval between two events taking place. Two events taking place. It refers to interval between two events taking place. In ancient times, we used some devices like sand clock, sundial, water clock and so on. For what? To find out the time. Okay. And now in modern days, we are using modern watches such as mechanical, digital, quartz and stopwatch. Clear? Yes. So this is what about time. Yes, children. Now about the second part, that is motion. So what do you mean by motion here? Motion is nothing but the movement of an object. What is motion? Movement of an object is said to be as motion. Clear? Again, this motion is divided into two types, that is uniform motion and non-uniform motion. Uniform and non-uniform motion. So what do you mean by uniform motion? When a body moves in a straight line path. When a body moves in a straight line path and covers equal distance at equal interval of time, then it's said to be as uniform motion. Uniform, equal distance in sense might be, for example, 50 kilometers, equal distance, and in case if it is covered by equal interval of time, for example 20 minutes or 30 minutes, if it is covered in that way, the same kilometer, then it's one example for uniform motion. Clear? Yes. The second part, that is non-uniform motion. So what do you mean by this non-uniform motion or non-uniform movement? Anything you can mention. So here the distance which is travelled by the body at fixed interval is not same. Distance might be 50 kilometer or 60 kilometer. The distance where we are covering the distance, if you are travelling through car, we can travel by 10 minutes. In case if you are travelling by auto, it might take some little more, that is 15 or 20 minutes. And if you are walking, automatically it will exceed. Is that not? So if the fixed interval is not same time, then it's said to be as non-uniform movement or motion. Clear? Yes. Next thing is about speed. Next is about speed. So what do you mean by speed? Distance covered by a body in unit time is said to be as speed. The distance covered by a body in unit time is said to be as speed. Okay, the unit for speed is meter per second. In short, m/s, meter per second, or else kilometer per hour, that is km per hr. Okay, so that's what about speed. So here ultimately we are going to learn about measurements and then time, then motion and speed. Clear, children? Yes. Yes, children. Now let us start the topic, that is time and motion. Clear? So in our daily routine we used to buy so many vegetables, oil, groceries, so many things from morning to evening, is it not? We used to measure and buy vegetables, milk, grocery and so many items. Commonly we use, so to buy all these things, to measure all these things, we use length, mass, time, temperature, some measuring quantities we are using, is it not? So those measuring quantities, length, mass, time, temperature, is said to be as physical quantity. Is said to be as physical quantity. So we have to follow uniform measurement system which is measured by standard objects. We have to measure uniform measurement system. So if you are buying 1 liter of oil, it should be 1 liter uniformly, is it not? Wherever you are buying, it should be 1 liter. So we have to follow a uniform measurement system which is measured by standard objects. As a result, so since there is a need, as a result, standard unit of measurement, that is in short SI unit, it came into existence. Clear? Being, and this SI unit is used in the present time. Clear? So we are measuring. So what do you mean by measurement? The proper definition for measurement is defined as the comparison of unknown quantity of same kind. Unknown quantity of the same kind. For example, 4 to 5 kg of vegetables, 4 to 5 liter of milk, how much ever. To measure the unknown quantity, we are using here measurement. We are using measurement. So to measure that, we are using standard systems. Is it not? Standard unit of measurement. This standard unit of measurement, we are going to learn about that. SI unit, that's what we used to tell in short. SI unit. SI unit. SI system, we are going to learn about length. Length is measured in terms of meter. Meter, that is in short m, which is denoted by m. Length is measured by meter, that is m. Clear? Then mass is measured by kilogram, which is denoted by kg. Mass, for example 2 kg, 3 kg and all. Then time. Time is measured in terms of second, which is denoted by the letter S. Which is denoted by S. Temperature is measured in terms of Kelvin. Kelvin, which is denoted by letter K. Which is denoted by letter K. So for each and everything we are having a specific unit and it's denoted by a specific letter. Clear? There are certain other system of measurement like Like the standard unit, SI unit, there are some more measurement units like foot, pound and second, that is in short FPS, then centimeter, gram and second, that is in short CGS, meter, kilogram and second, that is in short MKS. All these systems we are using. Clear? Yes. In ancient times, they used to mention 1 cubic. So they won't have this much units. Nowadays, it has been developed. But in ancient times, they used to mention, they were also measuring and giving in a proper amount. Is it not? Yes. So they used to mention 1 cubic. 1 cubic. And then 1 handspan. 1 handspan and 1 foot. You can refer to the picture which is there in the page number 186. 1 foot. Foot size is 1 foot. 1 handspan is 1 handspan. 1 cubic meter. Okay. So like this, there are different units of measurement. Clear? So let us learn one by one. So the first thing is about measurement of time. Measurement of time. So what do you mean by time? Time is a phenomenon by which human beings are observing and recording changes in the environment. In the environment. Time is a phenomenon by which human beings are observing and recording changes in the environment. Mean to say, if you are entering into a campus, you will be just writing in that record, that is checking in time and checking out time. Is it not? So everything, it's differentiated or denoted by a specific time. Okay. The standard unit of time is second. The standard unit of time is second, which is denoted by the letter S. It is denoted by S. 60 seconds make a minute. That is, 60 seconds is equal to 1 minute. MIN in short. Then 60 minutes make 1 hour. Okay. And 24 hours make 1 day. Make 1 day. 365 days make 1 year. 365 days is equal to 1 year. Then 10 years. 10 years is equal to 1 decade. 10 years is equal to 1 decade. Then 10 decades is equal to 1 century. 1 century. That is also equal to 100 years. 100 years. And 10 centuries is equal to 1000 years, or else it is also said to be as 1 millennium. What is that? 1 millennium. Clear? That is, 1 millennium is 10 centuries. So let us learn about each and everything in detail. So now let us learn further about time. Time is a duration between two events. Okay. In ancient time, people follow natural event times from one full moon. To measure the time, in ancient days they were following one full moon to new moon. One full moon to new moon, that is 15 days. And one full moon to next full moon, that is approximately 29 days or a month. Okay. Then time between one sunrise to the next is said to be as a day. One sunrise to the next sunrise is said to be as a day. And year is measured as time taken by earth to complete one revolution around the sun. Clear? So like this, they were in ancient days, time is scheduled as such and they are measuring like this. In ancient times, there were no clocks. They were not following clocks. They were not having clocks and all. But still, they know the time exactly. Is it not? Yes. So they were using sundial, sand clock and water clock. All these things in ancient days they were using to measure the time. So let us learn one by one. Yes children, now you can have a look at the picture of a sand clock at page number 187. You can see the picture. So this is sand clock. So with this they were finding out the time. How? We are going to learn about that. See, here you can see in the picture two glass bulb which is vertically connected by a narrow neck. Is it not? By narrow neck. Okay, and here what is there inside? Sand. That allows the sand pass from upper bulb to the lower one. Okay, so when it is flowed into the lower one, the clock is inverted to allow the sand to flow again. So this is how they will be measuring the time using this sand clock. So let us learn about that. Yes children, now about the same sand clock. So we saw the picture where there is a device which is used to measure the duration of time. You have seen the picture, sand clock, is it not? So what is this sand clock? It is a device used to measure the duration of time. How will we measure with that sand clock? It is made up of two glass bulbs. We saw that, is it not? Lower and upper. So these two glass bulbs are vertically connected by narrow neck. They are connected by narrow neck that allows sand from upper to lower. So sand will flow from upper bulb to lower bulb. When all sand has flowed into the lower bulb, the clock is inverted to allow the sand to flow again. See, here you are having two bulbs, upper bulb and lower bulb, is it not? Which is connected by a narrow neck. Same quantity of the sand will be there in the upper bulb. So now what happens? Automatically it will flow from upper to lower bulb, is it not? Now once it has been completely emptied, it has flowed into the lower bulb, then the clock is inverted. Again it will be inverted, okay, to allow the sand to flow again. So here the time taken by sand to fall from upper chamber to lower chamber remain fixed. So this helps in measuring time in multiples of single unit of this time, that is sand clock. So this is how you are measuring the time using the sand clock. Clear children? Yes. Yes children. Now you can see the picture which is there at the page number 188. The first one, figure 13.3, that is a sundial. Okay. So what is this sundial? A round structure with some measurements are there, is it not? Yes. So this instrument is based on the principle of shadow formation. Shadow formation. You are getting the shadow because of sunlight, is it not? Due to sunlight, which varies with the position of the sun in the sky. So sunlight position will vary. It depends on the position of sun in the sky. So based on that sunlight it receives, this instrument sundial will work, which is used here to measure the time. So let us learn about that. Yes children, now about the same sundial. So it is based on the principle, as I said, it's based on the principle of shadow formation. Where you are getting the shadow? From where? It is due to the sunlight. It is due to the sunlight. So you receive the sunlight from the sun, is it not? Which varies with the position of sun in the sky. And with this sunlight, shadow formation takes place, and based on the shadow formation here sundial works. Okay, so the main drawback in this instrument is they can be used only in the presence of sunlight. Only in the presence of sunlight. Mean to say, we cannot use this at night time. It's not used in night time or rainy or cloudy days. Clear children? Yes. So but still this is also one instrument what they are using to measure the time, sundial. Yes children, now you can see the picture, that is figure 13.4, a water clock. What is this? A water clock. So using this water clock they used to measure the time. Okay, so page number 188, you can see the picture, the water clock. So what is there? Here they have kept a bowl, okay, but a definite equal amount of water with a known amount of water. Then here this is the water supply, and here there is a wheel which is connected to a wheel where there is a dial also, where there is a dial. Okay, then you can see here down water which is collected in the reservoir. Water which is collected in the reservoir, and a scale nearby, and a scale nearby. Here water is floating. Okay, so this is what about the instrument. Now this instrument they are using here to measure the time. So we are going to learn about that. Yes children, now let us learn about the same, that is water clock. Water clock is a timekeeping device that works on principle of inward and outward regulated flow of water. Inward and outward regulated flow of water. Okay, so in the inward regulated flow method, a bowl marked with lines is filled with water. What they will be having? They will be having a bowl with the marked lines which is filled with water. Say for an example, it might be 100 ml or 200 ml. We know definitely this much amount of water is there. Okay, then the flow of water is regulated. Regulated in sense it's getting collected in a reservoir. Then the lines are marked to track the flow of water. So it will be collected down. So here till how much it is collected, to measure till how much it is collected, they are having some lines to track the flow of water that indicate the time. Say for an example 200 ml. So if it is filled 200 ml, it should be 20 minutes, it should be 15 minutes, like that. So they are using this water clock to measure the time. These are the different instruments what they are using in the ancient time to measure the time. What are they? Sand clock, water clock, sundial and all. Clear? Yes. Now let us learn about what they are using now in the modern days. Modern timekeepers. In modern clocks, electrical circuits which operate on batteries are used to make quartz crystal oscillate within them. So they are using nowadays electrical circuits on batteries which operate on batteries, and they are using quartz crystal also. Okay, so these clocks are also called quartz clocks. Why they are also called quartz clocks? They are having periodic motion of quartz crystal. It is used in the clock. That's why it is said to be as quartz clock. Since they have this quartz crystal, then that's why it's said to be as quartz clock. Okay, here a periodic motion of quartz crystal is used for timekeeping. So quartz crystal is subjected to a periodic motion or movement, and by using that they are tracking out the time. Clear? They are very accurate timekeepers. They are very accurate timekeepers. Since 1970, quartz clocks are widely used all over the world. So from 1970 onwards, they are using this quartz clock very commonly all over the world. Okay, then next important thing what they are using in modern days is digital clocks. What is this digital clocks? They are easier to read. They are easier to read. They do not have any hands for hour, minute and second. They do not have hands. Instead, time is displayed in digits like 09:50, 9:50, like that. Okay, so these are the things which they are using in modern days to find out the time. Clear, children? Yes. Now let us learn about the next instrument, that is simple pendulum. Yes, children, you can see the picture for oscillation of a pendulum. So this is about simple pendulum, which is at the page number 189. Okay, so you can see here 3 metal bobs. Is it not? It consists of small metallic bob which is tied to a string, and suspended from a fixed point. In the same fixed point, all the 3 metallic bobs are suspended. The rest position of the metallic bob is known as its mean position. The bob is used here, or it is made to swing in to and fro motion. It is made to swing to and fro direction. It is observed that the bob completes one to and fro motion in exactly same time. One to and fro motion in exactly same time. In other words, it repeats oscillation in equal intervals of time. It repeats oscillation in equal intervals of time. Here you can see 3 bobs, A, B and C. Is it not? Yes. Now here in this, the pendulum completes one complete oscillation. It completes one complete oscillation when its bob, starting from the mean position A, from here A, which is moved further to C, and then C to B, and then back to A. What I said, its bob starting from its mean position A moves to C, then C to B, and then back to A. Okay, here the time taken for each and every oscillation is same or equal. So with that we are finding out the time here. So let us learn about that. Yes, children, now let us learn about the same simple pendulum. It consists of small metallic bob which is tied to a string and suspended from a fixed point. We saw in the picture 3 small metallic bobs. Is it not? Yes. So that is suspended from a fixed point. The rest position of metallic bob is known as its mean position. The rest position is said to be as mean position. The bob is made to swing to and fro direction. Now we are having this metallic bob. It's allowed to move in a to and fro direction. Okay, yes. Now let us learn further. It is observed that Bob completes one to and fro motion in exactly same time. So if it takes 2 minutes for one oscillation, always it will take 2 minutes for one oscillation. The pendulum completes one complete oscillation when its bob, starting from its mean position A, it will move to C, and then C to B, then back to A. So this is how it oscillates. Okay, so one complete oscillation is from A to C, okay, and then C to B, then B back to A. Okay, then about amplitude. Amplitude, what do you mean by amplitude? The maximum displacement of a pendulum of either side of its mean position. The maximum displacement of a pendulum is said to be as amplitude. The maximum displacement of a pendulum is said to be as amplitude. Now what do you mean by the word displacement? AB or BC denotes amplitude of simple pendulum. It denotes the amplitude of simple pendulum. Now how we are using this instrument to measure the time? That is time period. If a simple pendulum takes 50 seconds, what is that? 50 seconds to complete 25 oscillation. If it takes 50 seconds to complete 25 oscillations, the average time for one complete oscillation is, that is 50 by 25. 50 is 50 seconds. Okay, and 25 is number of oscillation. So the average time for one oscillation is 50 by 25, that is 2 seconds. 2 seconds. Therefore, the time period of the simple pendulum is 2 seconds. For one oscillation, that is 2 seconds. So how much ever it has oscillated, we can calculate the time exactly. So this is also one simple pendulum where they are using to measure the time. Yes children, now let us learn about the second concept, that is motion. What do you mean by motion? The movement of an object is called its motion. The movement of an object is called its motion. For example, all human beings and animals can move from one place to another. Is it not? From one place to another without any external help. Is it not? We are free to move. Yes. Then a body is said to be in motion. When we are mentioning that the body is in motion, a body is said to be in motion of it changes its position with respect to time and surroundings. Based on time and surroundings, if the body is changing its position, then it's said to be as the body is in motion, that is, it's moving. Then, for example, flying birds, moving car, blades of fan and spinning of earth on its axis. All are moving, is it not? All are moving, they are moving in a particular motion. Then with respect to time and surroundings, next thing is about when a body is not changing its position, that is when it is not moving, not changing its position with respect to surroundings, it is said to be at rest. When it is not moving, then that position is said to be as rest. It's in rest. Fans are fixed on ceiling. Blackboards are fixed in classrooms. Is it not? So these are all examples of which are not moving, or rest position. Okay. So what we learned, one, the body which is moving or in motion. The second one, the body which is not moving or not changing its position, else it's also said to be as rest position. Clear? Yes. Now, there are two different types of motion, that is uniform motion and non-uniform motion. So, let us learn about that. What do you mean by uniform motion? When a body moving in a straight line path and covers equal distance in equal interval of time, mean to say 50 kilometers. 50 kilometers always, if it requires 10 minutes or 20 minutes equal interval of time, then it's said to be as uniform motion. Clear? For example, hands of clock. Always it takes uniform time, equal amount of time. Is it not? Then pendulum, simple pendulum. So this is what about uniform motion. The second thing is about non-uniform motion. Non-uniform motion. What is this? When the distance traveled by a body at a fixed interval of time, is not the same. Say for an example, 20 minutes. Within this 20 minutes, one of the thing, car can travel 100 kilometers. Within this 20 minutes, bus can travel 100 kilometers. Train more also. Is it not? That's what. When the distance traveled by a body at fixed interval of time is not the same. Fixed interval of time will be same, whereas the distance what they are traveling, what they are covering will be more or less. Then that is said to be as non-uniform motion. Non-uniform motion. An object which is non-uniform motion, it covers unequal distance. One might cover 20 kilometer, one might cover 200 kilometer, one might cover 100 kilometer. Unequal distance in same time interval, within 1 hour or half an hour, within that same time limit, different kilometers it can reach. For example, train, buses, cars and aeroplane. Is it not? Within 3 hours we can reach to Delhi. Is it not? So the distance is also different. And distance is also different, but the time interval might be within the same time limit we can travel. Is it not? So that's what that type of movement is said to be as non-uniform motion. Clear, children? Yes. Yes, children. Now about the last concept, that is speed. So one might travel fast, one might travel slow. Is it not? There is a difference in speed. Is it not? Yes. So let us learn about speed. Speed is defined as the distance covered by a body. Distance is denoted by the letter D, small letter D. In unit time, time is denoted by letter T. Okay. Now, speed is defined as the distance covered by body in unit time. The unit of speed is m by s, that is meter per second or kilometer per hour. Kilometer per hour. So the formula is speed is equal to distance covered by body, that is d, by time taken, that is t. S is equal to d by t, that is meter per second. Meter per second. So speed will always vary. If you are traveling by foot, it will take long. Is it not? If you are traveling by car, you can go fast. Is it not? Yes, there is a difference in speed. So to measure the speed, the formula is distance covered by body by time taken. Now, to ascertain the speed of a moving vehicle, here they have provided a speedometer. What is this? This is a device which is installed in front part of vehicle. In front part of vehicle. What is that? Speedometer. What is the purpose? To measure the speed of moving vehicle. Clear, children? Yes. To ascertain the distance travel by vehicle and odometer. O-D-O-M-E-T-E-R. Okay. This is fitted along with speedometer. So along with speedometer, odometer, another device is also fitted for what? To measure the distance traveled by the vehicle. So odometer and speedometer will be there in the vehicle. So when it is moving, we can find out the respective speed and distance also. Clear? Yes. So this is what about speed. Yes children. Now about distance time graph for uniform motion. What do you mean by uniform motion? As I said, when a body moving in a straight line where equal distance is covered at equal interval of time. Okay, that's what's said to be as uniform motion. For an example, we learned about clock, simple pendulum and all. Is it not? Yes. Now we are going to apply the same thing with a graph we are going to find. And distance time graph. Distance time graph. So one axis we are going to have distance, another axis we are going to have time. So here take a graph paper. You all know a graph paper. Is it not? Take a graph paper, draw two perpendicular lines on it representing x-axis and y-axis. So here you consider this as x-axis and this as y-axis. Clear? X and y. Now here put time on x-axis and distance on y-axis. Here in x-axis we took as time. Okay, so for example, each and every break, that is 10 minutes, 20 minutes, 30 minutes, 40 minutes, 50 minutes and 60 minutes and so on. Clear? And then here this axis we have taken for distance. Distance in y-axis. Put time on x-axis and distance in y-axis. Then select suitable scales to represent required quantities on both axes. So we are selecting suitable scales. For example, 1 centimeter is equal to 5 kilometer on y-axis. Is it not? The difference is 5 kilometer. Is it not? 605, 610, 15, 20, 25. The difference is 5 kilometer. Here the 1 centimeter is equal to 5 kilometer on y-axis. And here 1 centimeter is equal to 10 minutes on x-axis. 10 minutes on x-axis. Now plot points corresponding to each value on both the axes for the time and distance. Now we are going to plot the point corresponding each value. So when the car is at 600 kilometer, it's in, we are starting there, that is 0 minutes. Then 605 kilometer, then 605 kilometer, 10 minutes. 10 minutes was over. Then 610 kilometer, 20 minutes was over. Then 615 kilometer, here 30 minutes is over. 615, 30 minutes is over. Then 620, 40 minutes is over. 40 minutes. Then 625, 50 minutes. 625, 50 minutes. Is it not? So for every 5 minutes, here totally 25 minutes. For every 5 kilometer, sorry, for every 5 kilometer, so for totally 25 kilometer, 600 to 625, the car travels within a time period 50 minutes. 25 kilometer in 50 minutes. Okay. So this is what? Join all the points to obtain the straight line. So for the 10th minute, where it is? In 605 kilometer. Then 20th minute, 6:10, 30th 6:15. First plot the point, then join the dots or points to obtain the straight line. You got the straight line. So this straight line indicates car has moved at uniform speed and time. Uniform speed and time. Clear, children? So this is what about distance time graph. Yes, children. Now an activity for you all. What is that? Here, if an athlete takes 50 seconds to complete a race of 200 meter, find his speed. What I said? An athlete takes 50 seconds, this is time, to complete a race of 200 meter, this is distance. Now the formula to find the speed is equal to d by t, it is distance by time, and you're going to divide and give me the answer. Answer should be represented in meter per seconds. Clear? Then the second activity, a bus covered a distance of 480 kilometer in 8 hours and a train covered a distance of 1200 kilometer in 10 hours. Okay, which one is traveling faster, bus or train? How to find? This is 1200 kilometer, this is 480 kilometer. It's not same even. How to find? Apply the formula. S is equal to, that is speed is equal to distance by time. Same formula. First apply for bus. Distance by distance and this is time. So you'll be getting the answer in kilometer per hour. Why? Because the distance is measured in kilometer, mentioned in kilometer. So the answer you'll be getting in kilometer per hour. Then apply the same formula for train. Distance by time. So you'll be getting respective kilometer per hour. Then with the final results what you got, you want to conclude which one is faster, bus or train. Do it and forward in your mail, class email ID. Clear, children? Yes. So as of now we have learned time, speed, motion, uniform motion and non-uniform motion and all. Is it not? Yes. So with this we have come to an end of this chapter. So after watching the video, read the chapter thoroughly so that you can understand much better. Clear? So let's meet in the next class. Thank you all.